سڵاوتان لەبێ قوتابیانی عزیز گەشتینەوە لاتان بۆ تاواکردنی بابەتەکانی کیمیای پۆلی دوازە سیستەمی ئینگلیزی. For today we'll take the second part of the delta H calculation. This time we will use different technique which is called Hess's law. Last time I have explained the calculation of delta H based on the delta HF of the substances. Today we will calculate delta H inshallah with another technique which is called Hess's law. Okay, so first of all, let's define Hess's law. Hess's law, first of all, is used to calculate heat of reaction. You know, heat of reaction stands for delta H, enthalpy of reaction. So this is the main goal of Hess's law. Hess's law, first of all, the identification, or it's very important if you recognize the question is Hess's law or delta HF. Okay, so we have the following points for Hess's law. First of all, as I said, let's explain Hess's law. The overall enthalpy change in a reaction is equal to the sum of enthalpy changes for the individual steps. That means in this technique, in Hess's law, we have two things. One of them, the reaction, the overall reaction, this is one part, okay? And then along with the overall, we will have some individual reaction steps, some intermediate reactions, okay? So in Hess's law, we will have multiple reactions, one which is always overall with some steps. Look at it, my dear. How do you know if the question is related to Hess's law or not? First one, there must be multiple reactions. Okay, multiple reactions. In multiple reactions, one must be overall. Sometimes overall is given directly, or you should write the overall by yourself, like the rest of previous questions in the prior lesson. Okay, one overall with some steps or intermediates. Okay, so in Hess's law we will have overall with some steps. Most importantly, look at it. Overall is the one with the unknown. The one with unknown. This is we yani this is W, not we, with the unknown. The one with the unknown is the overall. Another important point. Never change overall. This is our goal. The goal cannot be changed. Only the steps can be changed. Okay, we can approach our goal with different steps. That means we can change our steps, but the goal, no, stays the same. I'll repeat the whole thing is from the first. In this technique, we will have multiple reactions. There must be multiple reactions. One overall with some steps. Which one is the overall? The one with the unknown is the overall. The one with the unknown is the overall, with some steps. We will change the steps into the form of the overall. Never change overall, my dear. Take this note, very important. This is a very important note. Take it. Look, never change overall, only change the steps. Good? Example, look. Find enthalpy for the following reaction using the following data. Very well. As you can see, we have three equations. 1, 2, 3. يكسر بلا ما مستوى هسه كتسان رياكشنك معناها ويكسر دلي أوتيا هسه لهسيش سونا دانا كان overall دانا كان دبتي overall. Which one is the overall? Away kawa value okay unknown. The one with the unknown is the overall, my dear. Look. Awayan delta H okay diarnia. So this will be the overall. Good? And these reactions will be the steps, the intermediate reactions. So these are the steps. And this is the overall. Good. Look at this. إلى لو بسياري أو هابه هواشي شرح دكم ديتيلي دم آني كزور بأساني شرح دكم باشا صوت أنا بسياري كم زحمة ديارة حتى أكل قلي آشنا دبي. Only the first question looks struggling because once you get familiar with this, then you know it will become a piece of cake, believe me, I promise. Good. We have overall with two steps. First of all, underline the whole substances in the overall. 1, 2, 3. We have 3 substances in the overall. 1, 2, 3. These are the steps. The first step and the second step. First step, second step. Good. Then try to find out the substances in the overall in the steps. Try to find out the overall substances inside of the steps. وربزانا أو substances overall لناو كام step بنيان هي. Good. C2H4. It can be seen in the first step. First step. Good. H2O, it's in both reactions. Just cross it. It's a hypocrite. So if we have a substance that has been repeated in more than a single reaction, just cross it. We don't depend that one. Don't take that one. Once a substance is repeated in some reactions, I mean in 2 or 3 reactions, just cross it. We don't need that one. Okay. C2H5OH, it's in the second step. It's in what? In the second step. Second step. Again, I'll repeat this again. This is the overall for the sake of the unknown. Good. Then we have the steps here. First step and second step. Or first intermediate. Good. Then try to find out the whole substances from the overall into the steps. C2H4, it's in the first step. First step. H2O, it's in both. We don't need this. C2H5OH, it's in the second step. Great. Then, try to compare 2 things. A substance in the overall with the steps. According to 2 things. The first one, try to compare number of mole. And then, second step, try to compare position. Look at this. C2H2. Since C2H2 is in the first reaction, well, first one, try to compare their number of moles. Here, there's 1 mole. But here, we have 2 moles here, right? 2 moles, 1 mole. We have to make them the same, similar. Look. So there are 2 options, either multiplying this by 2 or dividing this by 2. But if you remember, I said never change overall. Never change overall. We don't change this. So first reaction must be divided by 2 because this is 2, this is 1. Okay? First reaction is divided by 2. And then the position. This is other reactant, other reactant. We don't change anything. We have no problem with its position. Done with the first one. Then H2O, no. C2H5OH. Number of mole, it's 1. It's 1. Get. Number of mole is okay. But the position, it's other product side. This one, it's other reactant side. So how to make them similar? We have to switch the reaction. Reverse the reaction. Second reaction, reverse. Or flip. Switch, inverse. Good? Now, let's do the same thing here. Look, first reaction must be divided by 2. Okay, if I divide a reaction by 2, the volume must be divided by 2 also, of delta H. If a reaction is multiplied, delta H must be multiplied by the same factor. So now, since the first reaction divided by 2, delta H must be divided by 2 also. Divide this by 2, delta H equals to negative 1,400 kilojoules. Good. And the second reaction is reversed. Is what? Is reversed. So once a reaction is reversed, the sign, the arithmetic sign must be reversed. If it's positive, it might convert it into negative. Or if it's negative, it must be turned into positive. So since the second reaction is reversed, its value of delta H must be taken oppositely. I mean, with the opposite arithmetic sign. This is negative will become positive. 1, 3, 6, 7. Then just use your calculator, add them. Delta H equals to negative 33 kilojoules. This is the final answer. Looks very easy. Okay? Looks very easy. يعني अگر reaction چی؟ Look at this. أگر reaction چی؟ أگر equation كارليك چی؟ Multiply by any number, the value of delta H must be multiplied by the same factor of multiplication. بەڵام ئەگە هاتوو reaction divide هەر ژمارەشی بکەین دەبی delta H کەشی divide هەمان ژمارەی بکەین. Okay? و ئەگەر هاتوو reaction بالعکس کەینەوە سویچی کەین پێچوانەی بکەینەوە نیشانەکەی ساینەکەی arithmetic sign must be switched, must be reversed. Good? How to be sure if the solution is correct or not? چۆن بزانینەوە حەلەمان ڕاستە یان ڕاست نییە؟ How solution ڕاستە یان ڕاست نییە؟ I only show the extra step only for this question. For the rest, I'm just going to do the changes with the numbers, that's all. Okay? But for now, I'll show you how to be sure if the solution is correct or not. But for the other questions, you don't need this step. Assume this is an extra step. Look, first reaction is divided by 2. So take the whole equation divided by 2. 2C2H4 divided by 2 will become C2H4 plus 6O2 divided by 2, 3O2 to form 4HCO2 divided by 2, 2CO2 and 4H2O divided by 2, 2H2O. Good. How about this? Switched. How to flip a reaction, switch a reaction. So reaction is عكس كينوا. Reactant can be product. Product can be reactant. Take the reactants into the product side and bring the product side into the reactant side. Good. 2CO2 plus by 3H2O to form C2H5OH plus by 3O2. Good. Nice. One more thing. Reactants with reactants, they must be added. Product with product must be added. And reactants with products, they cancel out each other. 3O2 with 3O2 must be cancelled. Okay. It's cancelled. 2CO2 with 2CO2 is cancelled. And now 3H2O minus 2H2O, this is must be disappear. Only one H2O will be remained here. Here we will have one more H2O. Okay, 3 minus 2 is 1. Okay, so now what left? C2H4 with H2O here with C2H5OH here. C2H4 plus by H2O and to form C2H5OH. It must be the same as the overall. Yeah, this is the same as the overall. Then now we are sure that the solution is correct. It's done correctly. Okay? بەڵام ئەگەر هاتوو ئۆڤەڕۆڵمان لە بۆ دەرنەچیتەوە تاوان دیارە کێشەک هەبوو لە شوێنەشی ئەو ستێپەی ئەو هەنگاوەیە ئەنجام نادەم لە بۆ پرسیارەکانی کە هەر بە خێرایی ڕاستەخۆ I'm just going to show the changes with the values of delta H and that's all, okay? Let's take the first question here. Good. Look at this, my dear. Let me delete the solution. Look at this. Okay. Here is enough. Good, good, good. I think we already need this part. Great, great, great. All in say. Okay, look. Use the following reactions to calculate enthalpy of formation of methane CH4. First of all, as you can see, we have 3 reactions, right? So this is the Hess's law. Hess's law. Hess's law. Okay? in Hess's law, one of them must be overall and the other one must be the steps. The other reactions must be the steps, okay? Because all of them, they have their own values, so none of them is the overall. Hiç kayman overall nina, but hiç an unknown nina. By the way, mister, what mean by the following delta HF, delta HC? Later you will become familiar. So هر كاتجانا تبولي أنا هم يعني يكسانن بدلتا H. Don't worry, they are equal to the value of delta H. Don't worry. Later you will know what I mean by this. Okay, we have some extra questions. Good. So now, because none of them is the unknown, so all are steps. These are the steps. Which one is the overall? The overall must be created according to the unknown of the question. The question said formation of methane. This is the overall. Formation of methane is the overall. So my dear, please read the question carefully. Take out the overall in there, because all of them, they have their own values. So the overall must be inside of the question. Look, formation of methane. This is formation of methane. CH4 is produced from the combination of carbon and the H2 must be times by 2. Value of delta H equals to what? Very good. And now, carbon. Carbon, it's in which step? In the first step, okay? Position, both are located at the reactant side. Position is okay. The number of mole is also the same. 1 mole, 1 mole. Good. So take the first reaction, same. Take this value, same as it is. Delta H equals to negative 393.5 kilojoules. Oh, this is for the first one. And now, hydrogen. Hydrogen, it's in the second reaction, right? Position, this is other reactant, this is other reactant. Position is okay. Number of mole, this is 2, this is 1. This one must be multiplied by 2. Only change the steps. This one must be multiplied by 2 for the sake of this. So second delta H must be multiplied by 2. Delta H equals to negative 286 times 2. Get. Nice. And then CH4, it's in the third step, right? Position, this is other product, this is other reactant. So this one must be reversed. Must be what? Reversed. And number of mole is 1 by 1. So we don't multiply or divide the reaction, the third reaction, by anything. Just reverse it. Once I reverse a reaction, so the value of delta H must be switched the sign. Delta H equals to positive 890. And now just use your calculator, add them all. Okay, negative 75. Delta H equals to negative 75.5 kilojoules. Okay, this is for 1 mole. This is for what? This is for 1 mole, for the formation of 1 mole. Then calculate the enthalpy of formation for 2 moles. Okay, for this reaction, delta H, later you will know delta H and delta HF, they are the same. They are equal. Okay, or use the rule. Good. So this is for 1 mole. How about for 2 moles? Just do this. Delta H and mole number. I told you in this part of the book, number of mole, grams, anything else must be delayed for the end of the solution, please. For 1 mole, delta H equals to negative 75.5. How about for 2 moles? Just put X. Cross product. Done. Another question. Look at this, my dear. Okay. 100. Okay, it's nice. Look at this. Oh my God. Okay, good. Let's solve this question together. نبغى الريزلت كم بالي ديالي شباب من. It's nice. Okay, look. From the following steps, calculate the enthalpy of formation for 150 grams of pentane. Look, First of all, Mr. What to do with the mass given here? I told you, just wait for the end of the solution. تصاورك باب سيارك حل كين تخوا بلي تخوا يك دقراوا جراموش تانا ما نتصاورك تاخي بسياري وديار دي كينا مول دي كينا سي مول وا مول دكاتا سي mass over molar mass هناك okay and mass is 150 divided by 72 equals to 2.0 I don't know I'm not sure 2.08 moles, right? Okay, so this is number of mole, but what to do with it? Just wait. First let's solve the question for 1 mole, then make the cross product. First let's calculate delta H for how many moles? For 1 mole, then follow the cross product. Okay, which of the following is the overall? None of them. Why? Because you know any of them, they have their own value, right? So the overall must be created inside of the question. Formation of pentane. Pentane. Formation of pentane. C5H12 produced from the reaction between 5 carbon atoms plus the 6 hydrogen gas, molecule gas, right? Find delta H here. Sorry, my dears. Find delta H here. Nice. Then delta H has the same value as the enthalpy of formation. They are equal. Later you will know how. Okay. Get yalla. Carbon it's in the first step. So number of mole is 1 is 5. So multiply the first one by 5. Take the first one times by 5. Okay. The first delta H must be multiplied by 5. Then hydrogen, here it's at the reactant side, at the reactant. This is 6, this is 1, must be multiplied by 6. Take this number after its multiplication by 6. Good? And C5H12, number of mole is 1. This is in the third step is 1. Number of mole is okay, but position, this is other product, other reactant side must be reversed. So just take this number oppositely. I mean, the sign will become positive 35.6. Just use your calculator. You will get this result. So delta H equals to, now delta H equals to negative 146.7 kilojoules. This is for how many moles? This is for 1 mole, right? For 1 mole. How about for 2.08 mole? Just put X here. Cross products. Done. Another question. This is totally the same as previous questions. I'm not gonna waste your time with this. ويلا بابا بسيارة حلكين أو فكرة كيزيا زبا شبابي من دي عاقل بي يلا عفرين دي بابا بسيارة حلكين دي بابا عقاد لي ربي باو حلي بسرينو بيكو بزاينو بسيارة شكو حل دبي Okay, look. Calculate enthalpy of reaction. Enthalpy of reaction, it means calculate delta H, okay? Calculate delta H, use the following equations. As you can see, we have multiple equations again. So it stands for Hess's law. Hess's law, right? This is Hess's law because we have multiple reactions. Which one is the overall? None of them, because you know they have their own values. So the point is we have to write the overall based on the question. Look, the question said combustion of nitrogen monoxide. How to write combustion of nitrogen monoxide? 1 mole of the substance plus O2 to form nitrogen monoxide to form nitrogen dioxide gas, NO2. And then it must be balanced. Now it's balanced, okay? Let's find out the value of delta H for this equation. Look at this. NO can be seen in the first step, right? It's in the first step. First of all, number of mole is 1. Number of mole is okay. Position. This is other reactant side. Here it's other product. So the first equation must be reversed. Once a reaction is reversed, the value, the sign of the value must be reversed. So here we'll take opposite sign of this value. Will become negative 90.29. Okay, then O2, it's in both reactions. We don't take this. As I told you, this is a hypocrite. Good? NO2, it's in the second step, right? Number of mole is okay. Then position is okay. Take this number same as it is. 33.2. Just use your calculator. You'll get the answer very easily. Another question, which is, I'll leave this for you as your homework. This is easy. This is the most important question. I've seen this, I think, 3 times in Zhyar, okay? So be careful, my dears, with this. Okay, this is, I think, if you ask me which one is the most important question in this part of the book, I'll say conversion of graphite to diamond. The question is the most important. Okay, look at it, because the question, inside of the question, there is neither formation nor combustion. Good? Look, first of all, calculate delta H. Okay? Calculate delta H. To calculate delta H, as you check the values, you'll find out 2 reactions, which stands for, the technique stands for the Hess's law. Hess's law. Very good. Hess's law. Which one is the overall? None of them, as they have their own values of delta H. Very good. The point is how to write the overall based on the question, as I said, please. But this time, this is a conversion. It's not a combustion. It's neither combustion nor formation. So look at this. Let me tell you something. Conversion of A to B. It means A is the reactant and B is the product. How to write the reaction for any conversion? I mean the equation for any conversion. First, the one that is converted to the other must be a reactant and the other must be the product. Good? Look, conversion of graphite to diamond. So graphite is the reactant and diamond is the product. And since both are carbon atoms, so we will write the overall reaction. I will write the overall reaction here easily. Carbon graphite to carbon diamond. This is the overall reaction, okay? Look, carbon graphite is found, it can be seen in the first equation. Number of mole is okay, right? It's totally okay, number of mole. And then about the position, this is other reactant. We'll take this number same as it is, negative 394, okay? And for the diamond, look at this, diamond is in the second reaction. Number of mole 1 by 1, but you know the location is not okay, right? Position, location. Look, it's other product, this is other reactant, just switch it. We'll take opposite sign for the number, plus 396, then will become plus 2 kilojoules. The reaction is endothermic. Look at this, my dear. Let me tell you a trick about the exo and endo reactions. Okay? Assume the reaction is endo. If the reaction is endo, kilojoule must be written with the products, right? Or with the reactants, And if the reaction is exo, kilojoule must be written with the products. Product kilojoule, right? Okay? Look at this. This is the reaction arrow, right? Assume the reaction is endothermic. Guess what? Is endothermic. Endothermic kilojoule دبي لكامل بنوسين. Kilojoule دبي لكامل بنوسين. This is the arrow of the reaction. لأندوي kilojoule دبي بستسا reactanti. كديخينا سر reactanti ريك producti بس ريك reactanti لدي نوي دبي. يعني ها تشيلو يكيد دخينا سر reactanti reactant ريك نوي دبي. عوائل دي رسمه كذا لمستر يعني لإندوثيرميشي energy producti برستر للreactanti. وايا energy producti برستر للreactanti يعني ريك عوائل إندوثيرميشي. أو هاي لدي. reactant ليرة product ليرة دبي reactant من چه ليرة graphite product ليرة چه diamond ها دوباره ده كما بونم ناقر reactionك من هبي بابلين أو زارة exo okay this is the reaction arrow in the exothermic reaction كيلوجولي دخينا كاملة دخينا producti وعلى exo دخينا چه product إيه كيلوجول يعني تشيلو يكي ها put the kilojoule at the product side. Put the kilojoule at the product side will be like this. It means energy of reactant is higher than the energy of the product. It's just like this. This is for exothermic. Good? Okay, try to memorize the exo and indo like this. There amounts of exothermic وقت گرمی در. exothermic يعني چی؟ يعني گرمی در. لأكزوثيرمي چی که گرمی دره كيلوجول كي لكاميرا دنوسين كيلوجول دخينا صار برودكتي وكخصمان صار برودكتي راسخو برودكت قرزبي او هيدي يعني تمام اول شيء لاكزو ثيرميشي ادي استهيت من بونم نو برودكت رياكتان لاندو ثيرميشي كيلوجول دخينا صار كاميرا لاندو ثيرميشي دخينا صار رياكتانتي كيلوجول ما كخص صار رياكتانتي او رياكتانتوني هاريك او هيدي اللي هو اندو ثيرميكا يعني reactant ليري that's the product بوشي واسيدي okay and the one with lower energy level must be more stable ورا باو بسيارشتان لبو حال كم دي بابي من باو بسيارشتان لبو حال كم 22.8 moles I just took one of the results ورا فريم دي باو بسيارشتان لبو حال كم زوان تركيستان ليلة بيت كا Very good. Okay, look at this. Use the following thermodynamic data. Calculate enthalpy change. Find the value of delta H from the following equations. Okay, look at this. None of them is the overall as they have their own values. So the point is we have to write the overall by ourselves. Okay, the question said for the combustion of what? Of isooctane. Isooctane, C8H18. This is isooctane. How to write the combustion reaction? Plus by O2 to form CO2 plus what? Plus H2O balanced 8 carbons multiplied by 8. Then hydrogen times 9. We have 9 hydrogens along with 16 oxygens together will become 25. Okay, so this will be, I think, 25 over 2. Yeah, this is 25 over 2 oxygens. The point is we will cancel out this. Okay, look, 1 times 9 is 9 oxygens here. 2 times 8 will be 16. 9 plus 16 will become 25. Get. So now C8H18, it's in the third reaction or equation. Number of mole is the same in both. So, but their locations, positions different. So just switch the third one. Okay, we'll take opposite sign for this. Plus 224.13. Get. And then oxygen, it's in the first, it's in the second. We don't need this. Then CO2. CO2 is in the second equation. Okay. Number of position, both are located at the product side, but here we have 8 moles, here it's 1. So multiply the second one by 8. Good? Times negative 393.5 by 8. Okay? And then H2O. H2O is in the first reaction. They locate at the same side, but number of moles, this is 1, this is 9. Multiply the first one by 9. Negative 241.8 times 9, okay? And then the overall delta H will become negative 5100.05, something like this kilojoules, okay? This is delta H for the combustion of 1 mole. For the combustion of what? Of 1 mole. Delta H and the mole, okay? So for 1 mole, delta H equals to negative 5100.05. What if I say for 2 moles, just cross product? Or if I say, okay, look at this. For 2 moles, just cross product, right? cross product. This is cross product, assume. Good? What if I say for 30 grams? Okay, convert grams into mole, then cross product, right? And how about if I say for 2 kilograms? Convert kilograms into grams, then grams into mole, then cross product. What if I say for 1 gallon? For what? For 1 gallon. Okay, mister, it's okay for 1 gallon. Just tell me what is the mass of 1 gallon. 1 gallon equals to 2.6 kilograms. So instead of saying find the delta H for 2.6 kilograms, the question said for what is the change in enthalpy for 1 gallon, okay? If no, 1 gallon equals to 2.6 kilograms. The point is 2.6 kilograms must be turned into grams by multiplication with 1,000 will become 2,600 grams. Then divided the grams by the molar mass. Molar mass is 114 equals to 22 point something, right? And then put this number of mole here with cross product, you'll get the answer easily. This will be the last question, my dear. Take this as a very important question. Okay, look at this. I'll explain this as a very important question. Take this very special. Okay, calculate enthalpy of combustion. So combustion of C2H2 is the overall. Let me write the combustion reaction as the overall. C2H2 plus by O2 to form CO2 plus H2O, right? Multiply this by 2. Then 1 oxygen with 4 will become 5, will be 5 over 2. Good. Find delta H for this. Use the following thermodynamic data, okay? Look at this. If you check the values, you'll find out more than a single delta HC. Hopefully you remember. Hopefully you remember in my booklet in page 100, in page 218, I said if we have one delta HC, then try to use that delta HC for two things, for the overall reaction and as the value of delta H. But if we have two or more than one value of delta HC, then the question must be solved by Hess's law. Okay? So you have to write the reaction for all of them because we have more than a single delta HC. So you should write combustion reaction for this, combustion reaction for this, formation reaction for this. But okay, then you have to be, it obligates you to write the reaction for the third one even. Once you write the reaction for the first two data, then you have to write the reaction for the third one. Okay? So combustion of carbon plus O2 to form CO2, and delta H equals to negative 285.8. Good. Combustion of this is hydrogen. I'm really sorry, my dears. Okay, this is for carbon, but I just changed the number. Okay, combustion of carbon, right? The value is negative 393.5. Very good, kilojoule. And then combustion of hydrogen, H2 plus 1 over 2 O2 to form H2O. Delta H equals to negative 285.8. Okay, and then formation of C2H2. C2H2 must be written at the at the product side to is produced from the combination of two carbon atoms and a molecule of hydrogen gas. The value of, along with the value of delta H, which is positive 2 to 8. Then, use this equation to manipulate the following reactions to get the final value. That's all. Okay, will be the last question. From the following reactions, we have two reactions. By the way, what are these numbers? Oh, mister, these are values of delta H. Delta H equals to negative 2800 kilojoule. How about this? This is also a delta H value, negative 136 kilojoule. So where's the overall? Calculate the enthalpy of this reaction. This is the overall, my dear. Find delta H for this. Good? Okay. C2H4, it's in the first one. Divide this by 2. Right? H2O, it's in both. We don't need this. C2H5OH, it's in the first one. Just reversed. Reverse. So divide this number and take opposite sign of this will become negative 1400. Okay, this is divided by 2. And then opposite sign of this results plus 1367. Then use your calculator, you'll get the answer as it's shown here. Okay, that was the whole thing is about Hess's law. So stay tuned. In the next lesson, I'm going to solve the questions right here, which are really important. Let me show you. Wait. Yeah, okay. I will solve the questions right here, which are really important, okay? In the next lesson, inshallah, along with this, I will go to take the second section, which is section 2, okay? The driving forces. Taukat salamat bumenen, labir tambitan, wura tambaris bi, legal video ekanum bron, dilniabin tako taisali legal tandabum, wa, you know, I'm always here to answer all of your questions, my dear, okay? If you have any questions, send it to me. Just send it to me. You know, I will answer directly. Use my videos with my booklet. Believe me, يعني بس بأمل ما بدخوا. بعرف يعني كواحد أنا ما مستعمل كلام على درس بيدلهم، ما مستعمل كلام على درس بيدلهم. لقي فيديو كانوا بخوينا، لقى المكتبش وملزمة كش متحبي جل بعجلي. حتى عجم ملزمة كمني شد نبي. بابلين بياني إلى مكتبي بزانة سبابة تكتب يجوا إلى مكتبي بتصير مكتبي الشوكي فيديو كي متماشاكا والله لقطاب خاني زوزر أحسن دبي لبود. Don't lose this opportunity, my dear. Okay? بس بجولي به بس بجولي والله أصل باسين تيدا بري إن شاء الله. تصورين تزي باش خواتان لقل تاني دهتو.